In problems 13 through 16, we're basically continuing along with the same process that we've been doing previously. That is, we're trying to identify open intervals on which a function is increasing or decreasing. Only in these exercises, we're working with trigonometric functions. So let's take a look at number 13. And again, I would suggest if you're not very comfortable with trig functions, then use the graph to help you there. So I'm going to bring up the calculator and we'll enter sine of x minus 1, close the parentheses, sine of x parentheses minus 1. And for our window, we're going to go between 0 and 2 pi. You can actually type in 2 pi on your calculator and it will give you the exact thing. Now if you wanted to have pi over 2 as your sub-intervals there, you can say pi divided by 2 and get that. Now our sine and cosine normally oscillate between -1 and +1, but in this case, since we're subtracting by 1, we're actually going to shift it down, and so I'll start at -4, that's fine, but go up to +2 by 1, and we should get to see there what this function looks like. And again, we're trying to find the intervals on which the function is increasing or decreasing. And so I'm going to take a snapshot of this and put it on our workspace. So we start off with f of x is equal to sine of x minus 1. And again, that's sine parenthesis x close parenthesis minus 1, not sine of parentheses x minus 1 close parentheses. Then we need the first derivative. Well, the derivative of sine is cosine, and the derivative of 1 is 0, so our derivative for sine of x minus 1 is just cosine of x. And cosine of x is equal to 0 when, if you recall your unit circle, the unit circle, we would have that cosine is 0. Cosine of 0 is equal to 0, but cosine of 0 is equal to 1, but sine of 0 is equal to 0. At pi over 2, we have the opposite. We have cosine of pi over 2 is equal to 0, but sine of pi over 2 is equal to 1. At pi, we have cosine of pi is -1 and sine of pi is 0. At 3 pi over 2, we have cosine of 3 pi over 2 is 0 and sine of 3 pi over 2 is -1. So if I just say this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. So those are values that you should remember there. And so cosine is 0 whenever x is equal to pi over 2 or x is equal to 3 pi over 2, either of those two places. Alright, so next we're going to make our number line. We can start it at 0, we can end it at 2 pi, and we have pi over 2, which might be here, and we have 3 pi over 2, which might be over here. Now we need some test values for cosine rather. Our derivative is cosine of x, and we need some good values to test cosine at. Well, if you look at the unit circle that I drew there, from 0 to pi over 2, cosine is going from 1 down to 0. But it's still positive in there. So if all I'm looking at here is values of cosine, then cosine is positive there. Then from pi over 2 to 3 pi over 2, cosine goes from 0 to negative 1, and then from negative 1 back to 0. So everywhere in between pi over 2 and 3 pi over 2, cosine's values are going to be negative. And then finally, from 3 pi over 2, cosine starts at 0 and it's making its way up to 1, but it's positive. So in this interval, cosine is going to be positive, and so we say that the function is increasing from 0 to pi over 2, and also from 3 pi over 2 to 2 pi, and decreasing from pi over 2 to 3 pi over 2. Now we can see that up on the graph. Let's go take a look at that. Here is the point where x is pi over 2. So the function increases from 0 to pi over 2. This is the point where x is 3 pi over 2. And so between pi over 2 and 3 pi over 2, the function is decreasing and then increasing again from 3 pi over 2 to 2 pi. Right, so that's going to do it for that problem. Hopefully that helped out a little bit. Trigonometric functions are always complicated, and you really have to spend some time with them to be able to thoroughly understand. Hopefully this was of some value. We'll stop this here and go on to number 15 in the next video. We'll see. We have 7 minutes or so to complete this. Let's look at number 15 here. 15. Our function is y equals x minus 2 cosine of x, and our first derivative is going to be 1 minus 2 times the derivative of cosine is negative sine of x, and so we end up with 1 plus 2 sine of x. Then we want to set that equal to 0, and 1 plus 2 sine of x is equal to 0 when 2 sine of x is equal to negative 1, or sine of x is equal to negative 1/2. Okay, so I'm going to do something very similar to what I did with the unit circle. Only here we're not interested at where sine and cosine are 0. We're looking for where sine is equal to 1/2. And so that's going to be at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So at pi over 6, sine of pi over 6 is positive 1/2. At sine of 5 pi over 6, sine is also 1/2. Whenever y is positive, sine will be positive. Sine of 7 pi over 6 will be negative 1/2. When y is negative, sine will be negative, and sine of 11 pi over 6 is also negative 1/2. And so the places where Sine will be equal to negative 1/2 will be when x is equal to 7 pi over 6 and 11 pi over 6. Alright, so I'm going to quickly make a graph of this function here so that can assist us. And our function is x minus 2 cosine of x, and our window will still go from 0 to 2 pi, only will go from negative 4 to positive 4 by 1, and let's see if that does it. Well, we can't see the whole thing there, so I'm going to go and adjust my y to go up to 8. Let's see if that allows us to see the whole thing, and it does. So I'm going to take a picture of this and place it on our workspace so that we can see what's happening here. Now obviously our answers are clear from this point, but how would we do this? We know that we need to make a sine chart going from 0 to 2 pi, and we have 7 pi over 6, which is just past pi, and we have 11 pi over 6, which is almost to 2 pi. Now we need some test values in here. You recall that our derivative is right here, and we are testing y prime. So whenever sine of x is positive, this whole thing will be positive. And so sine is going to be positive everywhere that y is above the x-axis. But we can pick some very simple test points here. Let's pick x equals pi. When we plug that in, sine of pi is 0, and 2 times 0 is 0, 1 plus 0 is 1, so it's going to be positive there. And we can see that up until 7 pi over 6, the function is increasing. Now, we need a value between 7 pi over 6 and 11 pi over 6. The easiest place to do that would be 3 pi over 2, which we saw on the previous circle. Sine is negative 1, and 2 times negative 1 is negative 2, plus 1 is going to be negative there. Now we can tell from the graph that in that small space between 11 pi over 6 and 2 pi, the function actually starts increasing again. But the question is, how could we have told that without seeing the graph there? Because it's very difficult to find a test point between 11 pi over 6 and 2 pi. But we know this, going back to our different unit circles here. On the left over here, we knew that at 3 pi over 2, sine was negative 1. And by the time we got to 11 pi over 6, sine is negative 1/2. And we also know that at 0, sine is 0. So sine is making its way from negative 1 up to 0, but still a negative number. So my point is that in between here, that sine of x is going to be between 0 and negative 1/2. And if we pick a number such as negative 1/4 and plug it back in to our derivative, we get 2 times negative 1/4 is negative 1/2. 1 plus negative 1/2 is positive still. And so that's a way of seeing that. But you can use the calculator also at that point to kind of point you in the right direction. So let's just quickly summarize what we have here. The function is increasing from 0 to 7 pi over 6, and then again from 11 pi over 6 to 2 pi, and decreases from 7 pi over 6 to 11 pi over 6. And we'll end this video here.